Assalamu alaikum. This is Usman Mirza. Welcome back to my channel. In this video, we will discuss or solve the complete paper of paper number 2, which is Cambridge O Level, and this paper is 5054/21 in May June 2023. If you are new to my channel, please subscribe and press the bell icon. Without wasting any further time, I assume you have read the instructions. So let's get started with the question number 1. Okay, starting from question number 1. Question number 1 says an aircraft pull a glider along a runway as shown in figure 1.1. Okay. Further says figure 1.2 shows the speed of the glider during the first 12 seconds of the motion. And this is a speed time graph. Describe the motion of the glider in the first 12 seconds. Okay, ji. If we see the graph starting from the origin and it follows a straight line, and this point will be, the coordinates of this point will be 26,22, and then you see the speed which remain constant throughout the motion after the 6 seconds. So you write as from 0 to 6 seconds, the motion of the glider is described as uniform acceleration. Why uniform acceleration? Because you see a straight line and you can calculate the acceleration by taking the coordinates, or you can calculate with the help of gradient as well, or you simply divide the speed versus time, so you can get the acceleration as well. So we can calculate with the help of a coordinate system, and we use a formula we known as slope of this line, and we can calculate the acceleration by calculating the slope. So we have y2 minus y1 upon x2 minus x1, and we can get the numbers as 0, 0, and this can be written as x1, y1, and this can be written as x2, y2, and we can further calculate with the help of numbers 22 minus 0 divided by 6 minus 0, or you can get the calculation, and by using calculator you can get the answer, which is 3.7 meter per second square, and you can say this is a uniform acceleration of 3.7 meter per second square. 3.7 meter per second square. After that, after 6 seconds, from 6 to 12 seconds, the speed of the glider is constant at 22 meter per second, and there is no acceleration of that graph. So we can write hence acceleration is a 0, and body has a constant speed, which is 22 meter per second. Moving on to next. In the first 6 seconds of the motion, there is a resultant force of 1800 Newton on the glider. Using the increase in speed in the first 6 seconds, calculate the mass of the glider. So you can calculate the mass with the help of Newton's second law. You can calculate the mass with the help of Newton's second law, which states that Newton's second law of motion state that force is equal to mass into acceleration. You can calculate the mass of the glider by dividing the two parameters as force and acceleration. Force is equals to 1800 divided by acceleration comes out to be 3.7. When you divide these two parameters, you get the answer of 492 kilogram. Moving on, determine the distance traveled by glider in the first 6 seconds of its motion. You can calculate the distance with the help of, you can calculate simple the area of the graph. So you can calculate with the help of formula as well, and you can calculate with the help of area by calculating the area of that part from the shading region. This is the region. When you calculate the area of that shaded region, you can calculate the distance of 0 to 6 seconds. So by taking the area of the triangle, you know shape, and will be equals to area of triangle will be equals to distance traveled by the glider, and you can calculate with the help of speed multiplied by time. Speed multiplied by time into half. I can rewrite the formula so you can understand better. So it is equals to 1/2 base into height, which base will be equals to time and height will be equals to speed. 1/2 time will be equals to 6 seconds, and the speed is 22. by calculation the numbers, you can get the distance, which is equals to 66 meter. 66 meter distance traveled by the glider for first second 6 seconds of the motion. Okay, discussion part D. Part D says that the glider has no engine and stay in the air with the use of convection current. State what is meant by convection current. So convection current can be stated as the flow of fluid due to temperature difference. So in the conventional current, the hot air or gas spread out, and it is spread out further, and the cooler air or less hotter air cool downs, creating a closed continuous loop, and this formation is known as convection current. So suggest how the convection current suppose the glider is formed. So we can learn from the picture. The glider has no engine. In order to move in the air, it must create a downward upthrust force, known as upthrust force. And this upthrust force is basically generated by the temperature difference. When this object moves in the air, there is a temperature difference created in between the wings or the wings of the glider, and that temperature difference create a upthrust force or pressure from the downward direction in order to lift the glider. So by creating a temperature difference, we can basically generate a conventional current or the flow of the fluid, and that flow of the fluid help glider to move in the air. So we can write the glider need an upthrust force to lift or stay in the air. The glider need an upthrust force to lift or stay in air, and that is provided by the conventional current, convection current. So you can write that the conventional current help the glider to move forward or to lift or stay in the air. Okay, so moving on to question number 2. Question number 2 says, in a safety test, a car of mass 1100 kg traveling at a speed of 10 meter per second and collide with a stationary van of mass 3000 kg. After the collision, the car and the van move together with the velocity v. Figure 2.1 shows that the car and the van before and after the collision. Yes, they given the data here. So we can write as mass of car as m1 and velocity of the car as u1, and the van mass can be written as m2 for numbers, and the velocity can be written as u2. And after the collision, the two objects are attached to each other and they have a common velocity, and we can write v1 and v2 is equals to v. So the total momentum of the car and the van is conserved during the collision. So as we know, in both the collision, in elastic or inelastic collision, in both collision, momentum will remain conserved, total momentum will remain conserved. So first part says that define momentum. So we can define momentum as the product of mass and velocity. So we can define momentum as the quantity of motion contained in a body, or the product of mass and velocity is also known as momentum. What is the SI unit? SI unit of momentum can be found with the help of formula. So we can write the formula here. Momentum is equals to mass into velocity. So we generate with the help of formula. As we know, mass has a unit of kilogram and velocity has a unit of meter per second. So this is a unit of momentum, or you can write as Newton second as well. Calculate the velocity of the car and van after the collision. So we have to calculate the velocity, common velocity, when the two objects are stuck together. So we have to calculate the common velocity. To calculate the common velocity, we have to use the law of conservation of linear momentum, as the examiner told. This is in the total momentum of the car and the van is conserved during the collision. So we can write the law of conservation of linear momentum, and it states that each momentum is equals to final momentum, or before collision momentum should be equals to after collision momentum. Before collision, we can write the momentum of the two objects as m1 u1 plus m2 u2, and after the collision we can write m1 plus m2 v. because the velocities are combined, so two objects are combined, they have a common velocity, so we can write as v. Now plug in the values and calculate the value of v. We can write the formula here. v1 is equals to m1 u1 plus m2 u2 divided by m1 plus m2. So by plugging values we can get the number. So m1 is equals to, m1 we have 1100 into v1, which is 10, multiplied by m2 is 3000 into 0 divided by 1100 plus 3000. 1100 plus 3000. When you do the maths, you can get the answer, which is equals to 2.7 meter per second. 2.7 meter per second is the velocity of the object after the collision, or they have a common velocity of 2.7 meter per second. Calculate the total kinetic energy of the car and the van after the collision. After the collision, we have to use this velocity, and we can calculate the help of formula, which is equals to 1 upon 2 mv squared. So we have to use the both masses, because after the collision the object have a common velocity, and this common velocity contain the masses of the two objects. So we have to write the masses of the two objects here, and we can write m1 plus m2 into v squared. Now we have to plug in the values, which is m1 is 1100 plus 3000 into v, which is 2.7 squared. After do the maths, or you can calculate with the help of calculator as well, so you can get the answer approximately equals to 15,000 joules. 15,000 joules. You can write 1.5 exponent 4 joules. 1.5 exponent 4 joules you can write as well as. Part 2 says the state the transfer of energy that occur in the collision. So you know this type of collision is known as inelastic collision. In elastic collision, the energy is not conserved. In elastic collision, the energy is not conserved. After the collision, after the collision, the transfer of energy and means the kinetic energy is converted into heat and sound. Yani after the impact, the kinetic energy of the objects convert into thermal energy, and the sound when thermal energy can be written as the heat, and some energy is used to deform the shape of the car and the van, and some energy is used to deform the shape of car and the van. So moving on to next question. Moving on to question number 3. Question number 3 says figure 3.1 shows a circuit containing 3 resistors, a 12 volt power supply and an ammeter. Calculate the current in the 400 ohm resistor. So we know that this combination, this circuit contains 3 resistors, and 3 resistors are connected in a series with an ammeter and a DC supply. So we have to calculate the current through the resistors. As the resistors are connected in series, so we know that the current flow through the circuit will remain same. So we have to calculate the equivalent resistance of the circuit, equivalent resistance, and we know these resistors are connected in series, so we have to just add up the all values, which is can say R1, R2 and R3, and we can add the whole values, which is 400 and 200 and 100 ohms. So we get the total values up to 700 ohms is the equivalent resistance. Now we have to calculate the current. As we know the formula is using Ohm's law, we can calculate I is equals to V upon R equivalent. So V is equals to 12 divided by 700. Now we get the number, which is approximately equals to 0.017, or we can write 17 exponent minus 3 ampere. 17 exponent minus 3 ampere. So this is the value of the current, which is very small. So now in the second step, we have to calculate the power produced by the 400 ohm resistor. So we can use the formula power dissipation, and the formula is P is equals to I square R. We know the current, which is 17 exponent minus 3. We have to square it, and we use the 400 ohm resistor, which is equals to 400. So we can when do the math, we can get the answer, which is around 0.1156, or we can write 11.56 exponent minus 2 watts. So now we have to calculate the power. Now we have calculated the power, which is equals to 11.56 exponent minus 2 watts. Now the part C says the student use all the components as shown in the figure. We have 3 resistors, 1 ammeter, and 1 is the power supply. He connect them so that there is a largest possible current in each resistor. He has connected such that there is the largest current possible in each resistor. the current in the resistor is larger, in one resistor is larger than the current in the other two resistors. The student connect the ammeter into the circuit to measure the current in the resistor. Draw the circuit of the arrangement, label each resistor with the values of its resistance. So we have to design a circuit such that we have the current flow through the resistor is one resistor is larger than the other two resistors. So we know that if we want to calculate if the current, if I want to change the current, so I cannot apply the three resistors in series. We have to apply the three resistors in parallel. So to change the current, we have to change the combination as well. So we can draw our circuit in the parallel combination to change the current through the resistors. So we have one resistor and we have two resistors downward, and this is the formation of the circuit. So we have to apply the ammeter as well. So we can apply ammeter here. So we can write the numbers as 100 ohms and 400 ohms and 200 ohms. So when they are connected in series, they have a large resistance and current will be smaller here, and because the resistance is small, the current flow through this resistor will be large, and the larger current will be obtained by the ammeter. And we have to design such circuit that the ammeter has to measure the larger current and we get the larger number as well. Now we have to add up the supply as well to in order to draw the currents. So we can add up like this. This is our battery and this is a 12-volt battery, and this is the whole formation of the circuit. So moving on to our next question. Question number 4. A student pushes a drawing pen into a wooden board as shown in a figure. The area of the pen is connected to a finger. In contact with the finger is this. The area is known. The student pushes downward force which is approximate 26 Newton. The mass of the drawing pen is very small. Calculate the pressure by the finger on the drawing pen. So we have to calculate the pressure, and pressure is equals to force per unit area. We know the numbers 26 divided by 5 exponent minus 5, and this come out to be, when we do the math, so this answer will come out to be 5.2 exponent 5.2 exponent 5 Pascal, or you can write the unit Newton per meter square. So moving on, compare the force exerted by the finger on the pen with the force exerted by the drawing pen on the wooden board. So the force exerted by the finger on the drawing pen will be equals to the force exerted by the drawing pen on the wooden board, because according to Newton's third law of motion, these two forces are equal. So now moving on, question number 3 says, explain why the drawing pen goes into the wooden board, not into the finger. So we can explain the reason with the help of diagram. So you know that pressure can be defined as force per unit area. If the area is smaller, the pressure will be larger. So you know, at the bottom of the tip you see a smaller area, and a smaller area contain a larger pressure. Smaller area contain a high pressure or larger pressure. So we know at the bottom of the tip the pressure is large, and the upper surface of the tip has a larger area. So a larger area is greater and the pressure will be smaller. So we know that the pressure is greater in the at the bottom, and the pressure is smaller at the top of the board, at the top of the surface of the drawing pen. So we can write the difference in the surface area of the wooden and the finger. The difference is surface area of the wooden board and the drawing pen. So at the bottom we know that we have a smaller area and pressure is greater, and at the head of the pen, at the finger or head of the pen, we have a larger area, and the pressure is small. Pressure is small. That's why the drawing point goes on the wooden port, not on the finger, not on the finger. Figure 4.2 shows a water emerging from a plastic bag that contained a number of small holes. Explain why the water emerged from each hole in a direction at a right angle to the surface of the bag. So we know that according to Pascal law, the pressure is transmitted equally in all directions. So we can write the force from the water is at a right angle to the surface, and the pressure emerges from each hole in the same direction. Okay, moving on to question number 4, part B. Part B says that figure 4.2 shows water emerging from a plastic bag that contain a number of small holes as shown in the figure. Explain why the water emerges from each hole in a direction at a right angle to the surface of the bag. Because the force applying by the water on the surface is perpendicular, so the water emerges from each hole in a direction at a right angle to the surface. इसी बात को हम यहाँ पे मेंशन भी कर लेंगे. Because the force applied by the water is perpendicular or right angle or right angle to the surface of the bag, So the water emerges from each hole in a direction at right angle to the surface of the bag, and you can write according to Pascal law, the pressure is transmitted equally in all directions. You can write as well. You can write according to Pascal law as well. Pascal's law. Moving on. The holes of A and B are of the same size. A and B are of the same size. Explain why the water emerges faster from hole A than from the hole B. So you see, water emerging from A has a larger speed, as compared to at point B. It has a lower speed. We have to explain the reason. So the speed of this reflex or hole depend upon the height above the water. Height above the water. So let's say this is the point. This is a common point for both points. Then you can calculate the height of point A, which is higher. Let's say this is H1 and this is H2. So you see, since height H1 is greater than height H2, so velocity of hole or velocity of water from the reflex on the hole of water is depend upon under root 2gh, which is the height. So if height is greater, the velocity emerge faster. The water emerge faster from hole A than from the hole B. So we can write hole A is at a greater depth than the hole B. Hole A is at the greater height or depth than the hole B. Velocity of hole A is much greater than the velocity from the hole B, and with the help of formula we can justify it. Velocity of reflex will be equals to 2gh. If height is greater, the velocity comes from the hole A is much greater than the velocity from the hole B. Okay, moving on to question number 5. Question number 5 said figure 5.1 shows the particles molecules in a sample of liquid water. Explain using the idea about the particles why liquid expand more than the solid for the same temperature rise. If I rise the temperature of these particles by 1 degree, then why the liquid expand more than the solid? The liquid expand more than the solid because the liquid contains less intermolecular forces of attraction between the molecules or particle than the solid, so they spread easily than solid and gain velocity and kinetic energy faster than the solid. The boiling point of water is 100 degrees Celsius, as we know. State the boiling point of water in Kelvin temperature, so we have to convert the degree Celsius into Kelvin. So we add 273 in it, so we have 373 Kelvin. Moving on to next part, the temperature remains constant as the water turns from liquid to gas at the boiling point. So we know that the temperature will remain constant as the state of the matter changes. which is from liquid to gases at the boiling point. So we have to explain in terms of particle why the energy must be provided when the temperature remain constant. So we know that the liquid has intermolecular molecular force of attraction. To overcome this, to overcome these forces, you have to apply some energy. So that's why we have to apply some energy to compensate the intermolecular force of attraction. And when we apply these energy to overcome the intermolecular force of attraction, then the state change from liquid to gases. Okay, moving on to the next part, which is part C. An electric heater is used to heat a sample of metal as shown in figure. There is no thermal energy transfer from the metal to the surrounding during the heating. This is very an important statement which says that there is no thermal energy transfer from the metal to the surrounding during the heating, which means that there is no energy losses. So we can say that we can apply the law of conservation of energy, which state that the electrical energy which is provided by an electrical heater must be converted into thermal energy in order to heat the metal. So moving on to next scenario, this says that the metal has a mass of 200 grams, is initially at 50 degrees Celsius. So metal has a mass of 200 grams and is initially at 15 degrees Celsius. The heater is switched on for 2 minutes, and then the maximum temperature reached by the metal is T2 is 40 degrees Celsius. Calculate the specific heat capacity of the metal and show the working. So we know that the electrical energy is equals to thermal energy. Then electrical energy can be calculated. So we have a power of 20 watts. So we can write electrical energy as power into time, and we can write thermal energy as mc delta T, where C is the specific heat capacity of the metal. So we can rearrange the formula and plug in the values to calculate the number. So power is 20, time is 2 minutes, so we convert into 120 seconds. So we can write as 120 seconds divided by mass is 200 grams. So we can convert into, so we have a unit of grams. So we will not convert. So we have noticed here that the unit is in a grams. So we have to write same numbers, and the difference of temperature will be 40 minus 15, which is 25. When we do the mass, we can get the number which is approximately equals to 0.48 joules per grams into Celsius. We can write over here as well. So this is the specific heat capacity of the metal. So moving on. The headset in a lens as shown in figure. So we have a figure here which shows our display, which is an object, and a convex lens which is a converging image, lens. The display is the object of the lens. Lens at the magnifying glass and form a virtual image of the display. Describe where the display must be positioned relative to the focal length of the lens, for which lens to act as a magnifying glass for the image on the display. To convert the magnifying glass, or to act the lens act as a magnifying glass, so we have to position the object between the optical center. We have to place the object between the optical center and principal focal point of the lens. Place object between focal center and the focal points of the lens to get the magnifying image from the lens, or to form a virtual image of the display. Our virtual image is formed by the diverging rays of the light, by the diverging rays of the light ray by the diverging ray of the light An arrow of the display is 3.4 centimeter from the lens. So we have an object here. We can write O. The image is formed is 22 meter from the lens. So this is a lens. This is a lens, and we have an image at 22 centimeter. So we can write. We can just mark the values to represent the image distance, which is minus 22 centimeter, which is minus 22 centimeter. We use minus sign for the virtual image, for the virtual image. Virtual image. Figure 6.3 show arrow 0 in lens L and the virtual image I. So virtual image is I is here, lens L is here, and arrow image of the I draw a rigid scale of the 1:2. So what we have to do on figure 5.6.3, draw a ray diagram to show the formation of the virtual image. So we have to place, in order to get the virtual image, we have to place the object in between the optical center and the focal points. We already did that. So now in order to draw the image, we have a one line which is passes through the optical center. Let's say its optical center is this distance is 3.4 centimeter as shown in the question. So the focal length must be greater than the 3.4 centimeter in order to get the image. So we can say this is the focal length, which is approximate at 4 centimeter. So the ray will pass through the focal point. One ray passes, and other ray passes from the optical center and straight passes through the line. Since the line are not converge at one point, so we draw a back image. We draw a back image to calculate the virtual image. We draw a back rays in order to get the virtual image. We can draw with the help of scale. We can draw with the help of scale as well. So you get the image of this size at this point, and this is approximate minus 22 centimeter. Now you have to calculate the focal length of the lens. You know the object distance, you know the image distance. So you can calculate the focal length of the lens by using the lens formula. So you know the virtual image is formed, and this is magnified and erected image as well. The nature of the image are virtual, erected, and magnified. So we can calculate the focal length with the help of formula. So we know the formula as 1 upon f is equals to 1 upon u plus 1 upon v. So we can write the u distance, which is equals to 3.4 centimeter, and this is v, which is minus 22. 1 upon 3.4 plus 1 upon minus 22. When do the mass, we can calculate the LCM as well, and further do the mass, which is equals to 74.8, and 22 minus 3.4. 22 minus 3.4, this answer will come out to be 4.02 centimeter approximate value. So this is the focal length of the, which is approximately equals to 4.02 centimeter. Okay, moving on to question number 7. How passes through the barrier. Figure 7.1 shows a diagram made by a student of the crust in the pattern. So here is a diagram. It one way in which the student drawing of the crust is wrong. So you see the waves coming straight, and a slit gap is greater than the wavelength of a wave. Whenever a wave undergo diffraction, its speed and frequency does not change, so the wavelength. So whenever a wave undergoes diffraction, its speed and frequency of wave does not change, so as of wavelength. So wavelength does not change. So we see a larger gap between two crust. So we can say after passing through the barrier, the wavelength increases. So we can write as the wavelength increases as or after passing through the barrier. Or we can write this by drawn after passing through the gap should be curve or semicircle, but the student has drawn them as a straight line. So it should be like this. It should be a curved shape, but student has drawn a straight line. So you can write both reasons if you want, or you can write only one reason as well. So moving on, the gap in the barrier is now made smaller than the wavelength. Complete figure 7.2 with at least 3 crusts to show the new diffraction pattern. So they have They told that the gap in the barrier is now made smaller than the wavelength. So we can say that the wavelength is greater than the obstacle, or you can say size of the obstacle, size of the barrier, size of the barrier. In that scenario, your diffraction pattern will be strong. Diffraction pattern occur and it should be strong. So you see a semicircle shape of a wave like this, and there must be a proper gap. Means the gap between two waves must be similar. The gap, let's say it is 1 centimeter, so you have to draw like the two waves have a 1 centimeter gap, which means the common wavelength. So we can the distance between two consecutive identical parts of a wave is known as wavelength. So we have drawn the three consecutive crusts to show the new diffraction pattern, and for that our wavelength must be greater than the size of the obstacle to form a diffraction pattern or see a proper diffraction pattern. In the above figure, you see a large gap between the slit, and the wavelength is smaller than the size of the obstacle, so your diffraction pattern is not visible, or you can say is not occurring. So when you reduce the gap between the slits such that the wavelength of a wave is greater than the size of the obstacle, so you see a proper diffraction pattern. Okay, discussing question number 7, part C. Part C says that in one part of the repair tank, the water wave has a speed of 6 centimeter per second and a wavelength of 2 centimeter. We have given two parameters. One is speed and another is wavelength. The wave then passes through the shallow region of the tank. The speed of a wave in the shallow region is 4 centimeter per second. So we can write the speed of the shallow region is 4 centimeter per second. Define the term wavelength. So we can define the term wavelength as the distance between two consecutive crust or trough of a wave. So this is known as wavelength. Now we have to calculate the frequency of a wave which does not change. Either it passes through the wave through shallow region or in a deep region, the frequency of a wave does not change. So we can calculate the frequency with the help of above data. So we know that the wave velocity equation which says that V is equals to F lambda. So F will be equals to velocity upon, this is velocity. So velocity or speed is 6 and wavelength is 2. So we have a frequency of 3 Hz. Now calculate the wavelength in the shallow region, shallow part of the tank. So we know that the frequency does not change. Frequency does not change as the speed reduces, the wavelength should also be reduces. So we can calculate with the help of formula of above. We can write as Vs is equals to F lambda S. S means the shallow part of the tank. We can calculate the wavelength as lambda S will be equals to Vs divided by frequency. Vs have given by 4 divided by 3 comes out to be 1.33 centimeter. And you can see that if the speed of a wave decreases, the wavelength also decreases from 2 to 1.3 centimeter. Now moving on to next question. Question number 8 says a filament lamp is arranged above a shiny metal surface. Student read in a textbook that the light emitting diode is more efficient than the filament bulb. What is meant by the efficiency? We can define efficiency as efficiency can be defined. Efficiency we can write efficiency as output energy divided by input energy multiplied by 100. So we know that filament bulb, your filament lamp has more dissipation than the light emitting diode. So we can write the power dissipation in filament lamp is greater than the light emitting diode power emitting by the light emitting diode because its resistance is greater. So the power dissipation is greater in the filament lamp. So we can say that the efficiency of the light emitting diode is greater than the filament lamp. Now we have to moving on. This is why the efficiency of filament lamp is low. So we know that in filament lamp some part of energy or power is dissipated in the form of heat through resistor in the form of heat. So we have lesser output energy than the input, so its efficiency is low as compared to light emitting diode. The student consider replacing the filament lamp as shown in figure with the LED of the same brightness, data about the filament length and the suitable LED as shown in figure. So we have a filament lamp has input power is 120, and LED has an input power of 15, and we have an output efficiency of the filament lamp is 6.2%. We know that the efficiency of the LED is much greater than this because the dissipation power is less. So we can calculate, first we have to calculate the power output. When we get the power output, we can calculate the efficiency of a LED. So to calculate the power, we have to apply the same formula as we have discussed above. The efficiency can be written as power output divided by power input multiplied by 100. So we have to calculate the output power. So we can rearrange the formula as efficiency into input power divided by 100. So efficiency is 6.2 multiplied by input power, which is 120 divided by 100. When you do the maths, you can get the value, which is approximately equals to 7.44 watts. This is the output power. Now you have to calculate the efficiency of the LED bulb. To calculate the efficiency, you have to change the input. Just input and output will remain the same. So we can use the same formula as P out divided by P in multiplied by 100. Now we have to calculate the efficiency of LED. Just like diode. So we have to put the numbers. Output power is 7.44 divided by input power is 15. Input power is 15 and should be multiplied by 100 in order to calculate the percent value. So this comes out to be 49.6%. So you see that there is a greater efficiency because its power dissipation is low, and we have get the approximate value, which is approximately equals to 50%. Okay, moving on to question number 8, part C. The filament is connected to a live wire and a neutral wire in the main supply. The earth wire is in the main supply is connected to the shiny metal surface as shown in the figure 8.1. There is a fuse in the live wire. By accident, the live wire touched the shiny metal surface. So first we have to draw the circuit diagram in order to understand the scenario. So they said that the filament lamp is connected to the live wire and a neutral wire in the main supply. So we have to calculate the filament and diagram the filament here. So we have to apply the battery attached is the main supply. So this is positive and this is negative. This is our live wire, which is connected to the filament lamp. Another wire is connected to the neutral wire in the main supply. The earth wire in the main supply is connected to the shiny metal surface. So we have to connect the earth wire with the earth wire. This earth wire which is grounded, which is attached to the shiny metal surface. So now there is a fuse in the live wire. So we have to apply a fuse as well. The wire. So now we have to erase this and we have to connect the fuse. So this is the fuse. Which is present in the live wire. By accident, the live wire touches the shiny metal surface. The live wire touches the shiny metal surface. This is what then happened. So we know that the shiny metal surface have a low resistance, and the filament lamp has the larger resistance, and we know that the current want to pass through the smaller region where has a current want to pass through the smaller resistance, or you can know where is a hindrance is small. So when the live wire touches the shiny metal surface, the majority current passes through the shiny metal surface, and there is a fuse present. So the fuse, at some point the fuse will break and the circuit is also break as no current passes through the wire. So we have to write this. Fuse in the live wire. As the live wire touches the shiny metal surface, describe what happened. When the live wire touches the metal surface, the current passes through low resistive path, which is shiny metal surface. As the amount of current increases, the fuse current limit occurs, and the circuit breaks, and no current will flow to the circuit. And it behaves like an open circuit. Another similar time, the fuse is wrongly connected to the earth wire. Now we have the scenario, and now fuse is wrongly placed and it's connected to the earth wire, Now we have to eliminate this fuse from here, and we have to apply this fuse on with the earth wire with the earth wire like this, fuse here, and this is earth wire. This is now our fuse present. Now if I touches the shiny metal surface, live wire with the shiny metal surface, so because there is no fuse present, no fuse present in the live wire, the current will increases. If the person touches the shiny metal surface, it get shocked, and because the large current passes through the body. So we can write by connecting the fuse with the with the earth wire, the current drawn limit is eliminated, and huge current is drawn from the surface because it has low resistance. If the person touches the wire, current flows through the body into the ground, leading to a severe electric shock. Okay, moving on to question number 9. Question number 9 says the figure AC generator. Figure why there is voltage induced in a coil when the coil turns. A coil is turned by a shaft by any means of source. So shaft should be present over here. This is the shaft, and shaft is moving by any means. For example, you are moving a shaft, so you can rotate the coil. So what is the reason behind why the voltage is induced in the coil? So you know that there is a magnetic field present between the coil and the direction of the magnetic field lines are from the north to the south, and the magnetic field lines are present inside the coil. So whenever the coil moves, there is a when the coil moves, there is a change in magnetic field lines, or magnetic field, or you can say magnetic flux linked with the coil. So as the magnetic flux changes, there is an induced current or voltage. Whenever there is a change in magnetic flux or magnetic fields linked with the coil, there must be an induced current or voltage in a coil. So in figure B, 9.1, there the coil is horizontal with the side AB on the left. The output voltage is 6 volt. So in a diagram, when a coil is horizontally placed, the side AB on the left produces a voltage of 6 volt. So this is a horizontal position in which the diagram shows, and we are talking about this line. So in this scenario, you see there must be a force present. Or induced voltage is present due to change in magnetic flux, and that induced voltage is depend upon the sin theta parameter. So you see the direction of the length of the coil is this, and the magnetic field lines are perpendicular. So magnetic flux produced will be maximum from the side AB. If you notice side BS, orient the point this number SC or D. For BC, the magnetic field lines and the length of the conductor are parallel, so the angle between them will be 0 degree. So no induced EMF will be produced. No induced EMF produces appear, which is the side BC. And for the AD, same as BC, no induced EMF because magnetic field lines and the length of the conductor are opposite. So there will be no induced EMF in the coil. In that the CD parameter, the direction of current changes. The direction of current changes has the EMF produced by the coil will be negative. So now this is in a horizontal coil side with AB on the left, the output voltage is 6 volt. In figure 9.2, draw a line from each side of the box one of the circle voltage to show the voltage output when the coil is at different location. One line has been drawn to you. Yes, when a coil position is horizontal with AB on the left, you have achieved the voltage of 6 volt. The reason behind, because the EMF produced in the coil will be equals to maximum voltage into sine of theta. If sine of theta is maximum, you get the maximum voltage. If the sine of theta is minimum, you get the minimum voltage. For the coil horizontal with AB on the right side, as we have discussed, the value of the voltage will be negative. Direction changes. The direction change, the value will be negative. For the top side and the bottom side, there will be no induced EMF because sine theta parameter is zero. Sine theta parameter is zero because the magnetic field lines and the length of the conductor are parallel, or we can say the velocity and magnetic field are parallel. In two scenarios, the output voltage will be zero. The output voltage will be zero. So zero for top and bottom, and for right or left. For right, you get the 6 volt, and for the left you get the 6 volt, and for right you get minus 6 volt, because the direction of the velocity changes. Magnetic field lines are similar, but direction is opposite. As we move from C to D, the direction opposite, so you get the minus 6 volt here and plus 6 volt. Moving on to next part, and next part says that, okay, moving on to question number 9, part C, which says that both an AC generator and a DC motor contain both coil and brushes. Figure 9.1 shows how brushes are connected in a coil and AC generator. So in AC generator we have slip rings and 4 brushes. Draw a diagram to show how the brushes are connected in a coil in DC motor. So in DC motor we use a commutator known as split rings. To generate the power outputs, we use a split rings. Say there are forces on the sides of the coil in DC motor. Why there are forces on the side of the coils in DC motor? Why on the top and the bottom side are forces are not present? So we have to move upward to know the reason. So let's say this is a coil for DC motor, and the current flows from here. When the current flows from here, you know that the magnetic force is present, and we can calculate with the help of formula ILB sine of theta, which means that the current and magnetic field are perpendicular. You know that for the side AB, the current is moving upward, and the magnetic field are present from north pole to south pole, and they are perpendicular to each other. So we can say that the maximum force is present, hence the torque is present for the side AB. And for side BC, the current and magnetic field are parallel, hence no force are present. So if no force are present, then there is no torque produces, hence there only force are present on these sides of the coil, not on the up and bottom surfaces of the coil. So we write the same reason here. When a current is passing through the coil, when a current is passing through the coil, the coil experiences a magnetic force between right experience and opposite forces on the sides, on the left and right sides of the coil, and generate a torque on the coil, and it generates the torque on the coil, and no force is present on the top and bottom of the side, because magnetic field and current are parallel to each other, hence the magnetic force is zero. If magnetic force is zero, then the torque produced by that side is also zero. Okay, moving on to question number 10. Question number 10 says carbon 14 is an isotope of carbon. It undergo radioactive decay with the half-life of 6,000 years. So we have given a half-life of carbon 14. The age of a sample of wood is found using a carbon-14 that it is contained. Describe what happens during radioactive decay. So radioactive decay is an spontaneous spontaneous emission of radiation such as alpha, beta, and gamma radiations. Always the count rate of the carbon 14 in the sample of wood is initially 1600 count per minute. So we have a number of parent nuclei initially. This is the parent nuclei present initially. We can write number of parent nuclei present number of parent nuclei present. On graph 10.1, draw a graph to show how a current rate will be vary over 24,000 years. So we have a sleep time, or we can say the time duration for the sample, complete time duration of the sample. So we have initially count rate is marked with X. So we have initially start from 1600 counts per minute. So for first half cycle, for first half decay will be equal to 600, and 600 will comes to be in between 400 and 4000 and 8000, which is approximately right here. So this is 6000, and your sample will be half. So 1600 divided by half will come out to be approximately equals to 800. After second half life, your time duration will be 12,000, or your sample will be half, which is 800 divided by 2, and your sample will be on 400 times sleep. After third half life, your sample will be on 1800, which is in between 16,000 and 20,000, and your sample reduces to 200, or sample reduces to 200. You can mark over here. And after that, after 24,000 years, your sample will become approximately 100. Your value will be 100 counts per minute. So this is 100 counts per minute. After 24,000 years, your sample will remain 100 counts per minute. And now you can join the values to get an exponential decay graph. As we know, the sample is exponentially decaying, and you get the graph done. Now moving on, this is 18,000, this is 18,000, this is 12,000, and then you get the next number will be 24,000. So in the next part, name the apparatus to use to measure the radiation of the sample of wood, and describe how it is used to measure the count rate. The apparatus used must be Geiger Muller counter, which is GM counter, measures the radiations, measures the radiation or counts of the radiations. How the apparatus is used. So we have a radioactive sample, which is carbon 14 now, and when the radiations passes from this, radiations are coming from here, and here is a Geiger Muller counter in which the rod is present, and this applied with the count rate. This is our count rate. As the sample passes through it counts, and you measure the count rate of the sample. How many radiations are coming. They not tell about the which type of radiations are coming from the radioactive sample, but how many radiations are coming. So it can be described by the Geiger Muller counter. You want to describe how the count rate of the sample of age is used. How the count rate from a sample of wood is used to find its age. To measure, first you have to measure the count rate and use the graph to find the corresponding age of the count rate. So you have to use the graph. You can write measure the count rate first, count rate, and use the graph to find the corresponding age of the count rate. As we have discussed that for the count rate 100, we can say the age of the sample is 24,000. So as you can correspond to any count rate, and you get the age of the sample. So use the graphs to find the corresponding age of the count rate. Okay, moving on to question number 11. Question number 11 says table 11.1 show the detail of the 8 planets in the solar system. their average distance from the sun and their orbital time period and their average surface temperature. So complete 11.1 by adding the name of the three planets that are not given. So we know the planet which is closer to the sun is Mercury. So we can write Mercury here, then we have Venus, then Earth, then Mars, then Jupiter, which is the largest planet of the solar system. Jupiter, then Saturn, then Uranus. We can memorize these values or these numbers. Calculate the orbital speed of the Mars as it travels from the sun. So we have only calculate the orbital speed. So speed can be defined as distance upon time period, and distance can be calculated of the circular orbit, which is equals to 2 pi r divided by t. So we have to just add up the values, which is 2 pi, and r will be the radius of the Mars and the time period of the Mars. So Mars has a radius of this number, and we put the value 2.3 exponent 8 meter divided by time period will be equals to 5.9 exponent 7, 5.9 exponent 7. When you do the math, you get 24 kilometer per second. 24 kilometer per second. What is the relation between the distance of a planet of the sun and its orbital time period? According to Kepler's law, we can say the time period square is directly proportional to radius cube or distance of the planet from the sun cube. So this is the relation which is directly proportional. So you can write the distance of a planet from the sun and the star time period r, orbital time period r, directly proportional, and you can write the same relation as well. So in short, we can write they are directly proportional. They are directly proportional to each other. Directly proportional to each other. Moving on to next part. So that is like the relation between the distance from the sun and the average surface temperature of the planet. So if we observe the table, we see as the distance increases, we see the average surface temperature is also decreasing. So we can write as the distance increases, the average surface temperature is also reducing. So they have inversely proportional. As the distance from the sun increases, distance from the sun increases, the average surface temperature of planet is decreasing. So we can write they are inversely proportional. Describe in your description. Include any anomalies. Anomalies means they do not follow the trend. So as we observe in the chart, we see there is a value which is 167. Then the value increases. This has to be decreased, but the value is increases. Then after that, the all values are decreasing from 15 minus 65, then 110, then move forth. So we can say that the Venus does not follow the trend, and the Venus is an anomaly. Because Venus does not follow the trend. So we can write Venus planet is an anomaly.